Have you ever wondered what we would see if we kept traveling deeper and deeper into space, all the way to its very edge? What would actually exist at the absolute boundary of the universe? In the language of science and astronomy, when we talk about the end of the universe, we're not really talking about the edge of space. Instead, we're looking back through time, toward the earliest moments of the cosmos, when everything had just begun to exist. Since its launch in late 2021, the James Webb Space Telescope, JWST, has completely transformed our understanding of the universe in ways that even the world's greatest scientists never imagined. In this deep dive documentary, we'll explore the astonishing discoveries JWST has made at the farthest reaches of the observable universe, places so distant that they allow us to witness what appears to be the very beginning of time itself. We'll also discover how these groundbreaking observations are challenging many of our long-held beliefs about the Big Bang and the formation of galaxies. So, let's embark on an incredible journey to the oldest era of the universe. Before we move forward, it's important to understand how this remarkable telescope can actually look back in time. Whenever we gaze at the stars in the night sky, we aren't seeing them as they are today, we're seeing them as they were in the past. That's because light takes time to travel across space. For example, sunlight takes about 8 minutes to reach Earth. If the sun were to disappear this very moment, we wouldn't know until 8 minutes later. In other words, we're always seeing the sun as it existed 8 minutes ago. The same principle applies to the James Webb Space Telescope. When JWST observes the most distant galaxies, their light has been traveling toward us for more than 13.5 billion years. That means we're witnessing the universe as it appeared when it was still in its infancy. However, there's one major challenge: redshift. As the universe expands, the light coming from distant galaxies stretches to longer wavelengths, shifting from visible light into the infrared spectrum. Older telescopes, such as the Hubble Space Telescope, couldn't detect these extremely faint infrared signals from the earliest galaxies. To overcome this limitation, scientists built the James Webb Space Telescope. Equipped with a tennis court-sized sun shield and ultra-sensitive infrared instruments, JWST was positioned approximately 1.5 million kilometers from Earth at the L2 Lagrange point, where it can observe the cold, ancient light of the early universe without interference. Imagine a universe wrapped in complete darkness. After the Big Bang, the universe was an extremely hot and dense sea of energy. As it expanded, it gradually cooled, allowing the first atoms, mostly hydrogen and helium, to form. Yet, despite the existence of these atoms, there were still no stars, no galaxies, and no visible light. This mysterious period is known as the Cosmic Dark Ages. For decades, astronomers dreamed of observing the moment when this darkness finally ended, the birth of the very first stars and galaxies. That historic era is called the Cosmic Dawn, and thanks to the James Webb Space Telescope, JWST, humanity is finally witnessing it. Unlike previous space telescopes, JWST was specifically designed to detect extremely faint infrared light that has traveled across the universe for more than 13 billion years. This extraordinary capability has allowed it to peer farther back in time than ever before. One of JWST's earliest and most astonishing discoveries was an incredibly distant galaxy known as JADES, GS, Z14-0. The light from this galaxy has traveled for approximately 13.5 billion years before reaching Earth. What we see today is not the galaxy as it exists now, but as it appeared when the universe was only about 290 At first, years old. Astronomers expected these early galaxies to be tiny, dim, and poorly organized. According to traditional cosmological models, the first galaxies should have taken much longer to grow into large, bright structures. But reality turned out to be very different. The newly discovered galaxy was surprisingly bright, surprisingly massive, and far more mature than anyone had predicted. It appeared to have formed stars at an astonishing rate, suggesting that galaxy formation in the early universe may have happened much faster than existing theories had suggested. The surprises didn't end there. Using observations from the Atacama Large Millimeter/Submillimeter Array, ALMA, scientists detected traces of oxygen within this ancient galaxy. That discovery shocked the scientific community. Hydrogen and helium were created shortly after the Big Bang. But heavier elements such as oxygen are forged inside massive stars. These stars must live, evolve, explode as supernovae, and enrich surrounding space with heavier elements before oxygen can exist. For all of those processes to occur within less than 300 million years seemed almost impossible under traditional models of cosmic evolution. This raised an extraordinary question. Did the first generations of stars form and evolve far more rapidly than scientists had ever imagined? Or is there something fundamentally incomplete in our current understanding of how the universe evolved after the Big Bang? The discovery of these surprisingly mature galaxies has opened one of the most exciting debates in modern astronomy. Every new observation from JWST challenges long-standing assumptions and forces scientists to rethink how quickly the first stars, galaxies, and heavy elements appeared in the young universe. The cosmic dawn is no longer just a theoretical chapter in astronomy textbooks. For the first time in human history, we are witnessing it with our own eyes.